So today's lesson, I will talking about the electrical symbol. So this is a symbol for the incandescent lamp, and this is a incandescent lamp on wall. Here is a lamp holder. This one is spotlight. This is floodlight. This is signal lamp. This is a fluorescent light. This is a twin fluorescent light. This is discharge lamp. This is switchboard. And here is apply hot water system, HVAC, apply exhaust fan, air conditioner, AC. So those are symbols need to be utilized to prepare for the electrical diagram. Here is a switch, single pole switch, single pole push switch, two-way switch. So this diagram for the circuit diagram for the two-way switch. This is an intermediate switch, a three-way switch diagram. So this three-way switch here we utilize. This is an intermediate switch that is symbol. Here is a tie switch. Here is power 10 ampere socket outlet. So those are the diagram. Here is 50 ampere socket outlet 32 volt. This is the multiple outlet and special socket outlet 32 volt. And telecommunication outlet, this one, wall telephone, floor telephone, electric bell, electric cloud. Here is emergency switch, fan, and a fire alarm. So the use of those are symbols. You have to sketch the electrical equipment plan for the room. So this is the example electrical equipment plan for the room. We utilizing those are symbols and we can draw the plan. In the meantime, you also have to do the socket outlet detail plan. So the outlet number, outlet detail, and the row number you have to put. This is a long schedule. Here is a light white detail, white number, dial switch, and row. And this is appliance name and the row. All these have to be utilized when you prepare for the floor plan. Not only the symbol, but also the details in schedule has to be provided. Here is an emergency light, and a fan, fire alarm, and emergency fan. We also sketch the equipment plan for the room. We also list the type of the equipment. From the plan, the electrical equipment style, location, numbers are to be mentioned. So this is on the plan. So those are the equipment details are to be mentioned. So here are this is about the cable crimping tool. When you are using the cable joining, this tool for the cable crimping. So this is the crimp bar set. And this is the crimping component and accessory. Those are the crimp, red, blue, yellow. But when you are utilizing the crimping, appropriate symbol have to be utilized. On the crimp, this is for the yellow, this is blue, and this is red. So appropriate crimp type have to be utilized. And we're talking about the cable insulation. All cable wiring, including our wire, is required to be insulated. So we use the PVC insulation. So temperature rating for the PVC insulation is 75 degrees centigrade. Voltage rating is 0.6/1 kilovolt. So this is for the PVC insulation. The next one is the functional insulation. Functional insulation. So this is for the PVC. This is the functional. This is the conductor. Hidden. Single or the multi-core cable are required to be protected against electronic noise or the interference that has the outer layer of the breaking or the bare copper known as the hidden or screening. Flexible cable. The connection of flexibles are applied. It must be a ribbon cable. So this is the kind of the flexible cable. Data cable. Data cable is any data media that allows the base and the transmission binary 1-0 from the transmitter to receiver. So Ethernet cable category 5, category 5C, category 6, category 6E. Those are the kind of the Ethernet cable. Token cable is a category 4, coaxial cable. Phase and a digital data. The serial digital interface and the thickness. So here is a coaxial cables as transmission. Obligate fiber cables are the fiber copies are communication. So here is a standard core, and here the first one is a dielectric insulator, then the metal sheet is above, and then finally the plastic jacket. Design choice affect the physical choice, attenuation, power handling, flexibility, and strength and cost. Those are the affecting, influencing the design of the obligatory fiber cable. Cable connector. We use the power, use the cable connector. Secondly, we have to use the RF connector or the F-type connector or N-type connector. Those are utilized for the secondary cable. Power, we use the power connector. So the fiber optic cable. The fiber optic cable has the faster speed, and they can transmit the longer distance, and better reliability, and the thinner flexibility, and low cost. Optical fibers are the lower power loss, the greater bandwidth than the metal cable. Their standing are the most flexibility. Screening is used to reduce the effect of the electronics interference or the EMI noise. Sabin, the outer layer of the protection is a form of the trying to wrap it as tightly as possible around the line, weather and mechanical protection. Flexible cost, we use a heavy duty sheet type. They comply with the AS 3000 2060, cross 4x3 and 3x9x7x4. Joining the termination of the cables, we use the cable connector. We also have to utilize the cable 2 and the cable last. So here connector, here cable last. We put here and we are pressed with the cable 2. Depending on the connector side, choose and applies color cable last. So in this case, we have to utilize red, blue, and yellow. So this is for the, we have to utilize this appropriate cable practical 1. Cable type and the cable termination method, we have to utilize this predicate. So here is a so MIMS cables are joining. So MIMS cable diagram. So this is the MIMS cable. So this is the joining method for the MIMS cable. We use this is the kind of the cables we join the cable lock. Cables are crimped cable. Also, we also have to utilize the soldering. So here, this is cable here, and then here we are frame, and then we get to solder. So single conductor, we have to utilize the soldering gun. And if you use a large conductor, you have to use a blow top and heat the conductor and feed the lead. So this is soldering method. So first step, we have to use a cable like this. After that, you tap the connection and then you have to solder. So the work procedure, cut the 300 millimeter of the each of the following connector, 2x5 square millimeter, 4 square millimeter, 6 square millimeter, 16 square millimeter. Use a knife to remove the insulation and the connector. Fit the clean last at the one of the each. Split the other end of the connector. Slide and join them as in the diagram and the solder. Use a polymer gas lamp to solder the cable together. So this is a soldering method. So we have to utilize a briefly describe the difference between side plane and the floor plane. Side plane is show the outline of the building, laws, and the position of building on the law. Floor plane is this is a drawing of the house viewed from above with the roof, ceilings and the parts of the wall remote. Briefly describe the function of the detailed drawing. These are the larger scale drawing used to clearly show the details of a specific area of construction where the greater details need to be shown. So this is for the electrical circuit diagram. When you draw this diagram showing the method used to flow plan. So this is a electrical square diagram, and in this case here is a circuit diagram. Then we have to utilize the details switch connection. So this is a look at the line method is utilized to wire up the switch. So this wiring diagram for wiring is a process on how the electrical schedule is converted to the practical working diagram. So in the practical scale, line length is a 75 meter. In this case, utilize the scale 1 to 100. So actual length is 75 to 100. This is a 7,500 millimeter or a 7.5 meter. So we also have to indicate the actual length of this length of the following. So in this case, 60 millimeter, 32 millimeter, 4.5 millimeter, 105, 115 millimeter, and this is a scale. You have to do the thing. So this is we have to identify the ES and say 11024 for the symbol. So this is a 2 fluorescent light. This is the exhaust fan, blue telephone, intermediate switch, and 50 ampere socket multiple outlet. Drone S1102, drone AS1102 architecture as electrical location symbol. So the luminous face to wall, this is a spotlight, this is a distribution board, this is a 2-pole switch, and this is a meter board. And also have to briefly explain the meaning of the standard drawing. So drawing or the illustration that is accurate and comprehensive and not to be used in different projects. Name the 5 parts of the electrical installation that may have their location or route determined from the site. In this case, equipment, light point, outlet, switch, relevant accuracy, layout, conduit, those you have to do this exercise. And also who has a responsibility of determining the cable route for the various circuit or domestic installation. This is the installing electrician. Installing electrician. So strengthening in the wire, it makes them more flexible. Cable serving, there can be the bilar or extruded PVC sheet. They are provided with the both mechanical protection and the insulation as well as HLPE screen. They must be used for the more than 50 volt AC. Cable color, single phase, 3-phase. So you use a black is an active, red is an active, black is a neutral, green, yellow is R. And also similarly, brown is active, light blue neutral, and the green yellow will be R. So this is the AS standard is the active for red, neutral for the black, and the R for green and yellow. But for the European standard, brown represents the active, light blue represents the neutral, and the green yellow represents the R. Connection for the insulated power cable. So we had to use a solder cable together. So we had to make a sleeve, and you can put a crimping, and then you can solder in. So in this case, the cable joint I utilized. In this case, we use a metallic sleeve and press with the crimping tool. And preparing there's a conductor combination of the connection. So in this case, the AS 3.7 by 2.2 have to be utilized to preparing for the connection. The insulation on the conductor shall not be removed any further than it is necessary to make the connection. So we have to strip the 25 millimeter of the insulation of the cable. We have to utilize a knife, plier, wire stripper. Do not cut the metal cord. Screw in the cord. Cable clamp to be utilized to screw out the cord on the wall. Other conductor connection on the applies not classified as a double insulated must be added and are provided with the terminal especially for this purpose. So in this case, a class 1 and 2 application. We use as a voltage. USA, Japan, North, South America, we use 100 to 130 volt for 60 hertz a single phase. Asia, Africa, Australia, New Zealand, Europe, we use the 220 to 240 volt, 50 hertz for the single phase. Minimum resistance between active and neutral conductor must be the 1 mega ohm. We have to test by the mega ohm meter insulation tester. So this is for the cables crimpings terminals diagram. So this is the cable, this is for the cable. So you have to make this cable exercise. So this is the soldering, cable solder. Here is the cable soldering diagram. This is cable solder. So this is we had to find the exploding hazard safety data sheet of the solder. And here is the hazard protection. And we use as an electrical diagram. The main of the communication in which idea, concept, or the specific detail are communicated. So this is the electrical diagram meaning. 5 types of the diagram used in the electrical electronic industry. They are the block diagram, circuit diagram, wiring diagram, agricultural diagram, and the ladder diagram. Block diagram is we use the exhaust fan, 230 volts AC, fluorescent light, and ceiling fan. So this is for the switch, exhaust fan. This is for the timer switch, fluorescent light, and fluorescent light. So this is between active and neutral. This diagram is block diagram. And also circuit diagram. So this is a detailed circuit diagram. So this block diagram, based on this block diagram, we draw the circuit diagram. This is a circuit diagram for the exhaust fan. This is a circuit diagram for the timer switch and light row. And here is a wiring diagram. Wiring diagram is a details of electrical at the light neutral arc. So this is look at the light method, and this is look at the switch method. So those are the wiring diagram. Here we architectural diagram is a 5-volt, and this is for the connection, and this is for the control. And here is ladder diagram. So this is for the 5 volts fluorescent light, and this is for the others light socket outlet, the wiring diagram. Here is a ladder diagram. Firstly is a timer is controlling the switch 1 to 3. Switch 2 control the fluorescent light 5 volt. Switch 3 control the fluorescent light row 1, and the switch 4 control the fluorescent light row 2 and 3. So this is the ladder diagram. So this is simple exercise regarding the wiring diagram, ladder diagram. And here is a direct online starter connection. Direct online motor starter connection. So this is for the circuit diagram, this is wiring diagram. So here is a conductor, we are holding coil, this is holding an AC holding coil, this is the start switch, stop switch, and this is the 3-phase motor. So this is wiring diagram, this is the circuit diagram. Then we are talking about the selecting the appropriate cord. When you do the electrical installation, we have to select the appropriate cord is important. The point that must be considered for selecting the cord for the particular application. So the current cord, the cord is expected to carry number of the coils and the condition under which the cord to be utilized. The flexible cord must have the capacity to carry the current not less than the rating of the equipment to which they are connected. So here is a current rating of the appliance, current rating, and this is number of diameter water, wire, and this is nominal area of the conductor. So those are this table. So here we see the cable type and appropriate usage. So this is cable type. The pair 2 cord, in this case, conductor side we 0.5 millimeter square, 0.75 millimeter square. We use a hand sheet, the base insulated applies, not more than 3 ampere. The base insulated applied, not dampness. Light duty sheet, we use a minimum of 0.75 millimeter square. Non-double insulated applied can be used for the dampness. Ordinary duty sheeted is a minimum 0.75 millimeter square. Not a double insulated can use in a dampness flexible cord extension. Heavy duty sheet, in this case, minimum 0.75 millimeter square. So we use it as the same as a full. The size of brazier overall minimum is a 0.56 millimeter square. The S bar 3. So those things are the kind of the table and their appropriate usage. So here we use as a cord. Left side is an active, right is a neutral, and bottom one is a R. So in this case, when you are joining the plug, so this will be the active neutral R. Active can be the red or brown. And this is R with green, yellow, and neutral is a black or blue. So those are the active neutral R diagram. So we use as two other cord by the cable clamp on the wall. Why is it possible? We double over the end of the conductor before it is inserted to the tunnel type conductor. So in this case, the fine answer is to create the conductor. So this is the conductor here. You have to bend this way, and then you can screw. ASR 1.4 by 36. So this mention about the flexible cord. Not AC the 0.3 millimeter diameter. No conductor AC 4 millimeter square cross sectional area, and not more than the 5 volts. So this is for the AS 1.4 by 36 restriction. Protection rating of the internal protections IB rating. So IB rating indicates that the level of the protection against the entry of wire and the foreign bodies into plus or the socket enclosure. So IB type will be IB. IB is internal protection. So 2 indicate the first character 06, and 3 is a second character 08, and C means appropriate less optional. H means ABCD. So in this case, additional letter will be optional. It can be the A and the SW. So in this case, the function is that you have to protect against the hazard touch with the finger, protection against the ingress of the solids. So it can be the 112.5 millimeter diameter or greater. Protection against the harmful effect of the water spray. Protection. So this is for the 2 is a protection against the hazardous pass. 3 indicate the protection against the harmful effect of the water spray. C means the protection of person handling to having a diameter 215 millimeter, H being the hydraulic apparatus. So those are the H and WS, they are medium, and this is protection level, they are medium like this. So this is the IB protections method. Here is a IB coast table. So in this case, we have to see this G1004, section 2, page 910. In this case, also the in the electrical trade 2018.blogspot.com. This is pin configuration of the plug. So single power plug and socket. Here is 10 ampere 240 volt, 250 volt, 15 ampere 250 volt, 20 ampere 250 volt, 25 ampere 250 volt. Also the 10 ampere 250 volt, here is 20 ampere 250 volt, 32 ampere 250 volt, 10 ampere 250 volt special purpose. So in this is a three-phase plus diagram. So A1, A2, A3 are three-phase neutral and arc. Here is a base and neutral blue, and here is a brown. Bottom is a arc yellow and green connector. So in this case, left side active, right side neutral, bottom is the arc. So this is the connection diagram. Insulation resistance active to neutral must be greater than 1 mega ohm, and also socket outlet. We have to check the polarity of the socket outlet. Which one is active, which one is neutral, which one is arc. We have to check the polarity of the socket outlet. What is the difference between the 10 ampere 250 volt socket and the 20 ampere 250 volt socket? In the side of the pen hole is bigger in the 20 ampere 250 volt socket. And what is the 15 ampere 250 volt plug fits into 10 ampere 250 volt socket? So answer will be no. So those students are doing this cable stripping. Cable crimping. So this is the function of the cable crimp. We fix this cable. Here is a tool for the insulated tool. So this is the we measure the cable insulation. So this is this tool. Cable insulation resistance measurement tool. Here is forward reverse starter connection diagram. So in this case, the interlock is here. Here is TOS thermal overload. This is normally open. This is normally closed. Here is a magnetic interlock. So this is forward reverse connection diagrams. Start stop holding coil, forward holding coil switch. So this is the interlock method. Interlock method is we cannot press the forward and reverse switch together. So this way we have to be do this interlock. By providing interlock, it can prevent the magnetic line-to-line short, line-to-line fault. So this is the connection of the forward reverse connection diagram to the electrical circuit diagram, and this is for the circuit diagram. Here is the practical both connection. This is forward reverse switch. So this is those are circuit diagram. Those circuit diagram. This is the practical wiring diagram. So this is the arrangement of the switchboard. By pressing the H1, H2, or by pressing the H3, so it energizes the magnetic switch. So this is the how the magnetic switch is energized and how the operation is performed. So this one mentioned about the by pressing the H1, H2, by pressing the H3, it energizes the magnetic. So result is by energizing the magnetic coil Y1, Y2, so the conductor in the line 2. And by pressing the H5, Y1 is already closed and it can energize the Y2 holding coil. And closing on the Y1 contact, line 3 energized, contact 1, but it can be inserted by the pressing H1. So after the counting the period, counter 1 will close the contact in line 4 so that the Y3 coil is energized and then it closes the respective contact in the final socket outlet. So this is for the timers operations are set. So here is a symbol of the normally closed, normally open. Also the normally opens are timer conductor, the close timing. Also this is a diagram of the pure circuit breaker, normally open and normally closed. Those circuit diagram. So this is a ladder diagram. Ladder diagram is a ladder diagram. The firstly operation. This is line 1 is an operation. And after the line 2 operate and then the line 3 equipment are operate, line 4 equipment are operate. So those are operations that is a ladder diagram and they are function. their function is described here. So this is details are operation principles are described in here. So the CSA of the conductor is flexible core used to supply the apply is determined by the load current required by machine. While upping of the 3-way ply longer than the other two. Upping is applied before the electrical current flow into the equipment to protect the earth leakage. Why is a upping of the 3-pin plus sometimes wider than the other two? The function assigned to reduce the earth resistance. TPS wiring system, the main reason is quickly and easily wired for the surface walk. Is more flexible. Is used to all the electrical equipment available with them without earthing. So this will be the disadvantage. Is prone to the mechanical damage. During it can be damaged by the rodent and the presence of the excessive temperature can damage the and degrade the wire. Type of the TPS wire are the flat and the circular. TPS cable sheet is a wire, white, black, and the gray. Red sheets are the secondaries light circuit wire in the 224 circuit. They also utilize for the interconnection between the smoke conductor. So TPS conductor in trunking, this is the trunking diagram. TPS cable we run here. In this case, we had to follow the AS3000 cross up 1.4Y 127. So it's meaning that it trunk all the true for the housing and the protection, electrical cable and the conductors. Also, the cables are rating. Cable rating is derated if more than one circuit in trunking. So in this case, we follow the clause 3.10.59 cable trunking method. The cover Chevys are able to open where the predictable, the cover, the all cover Chevy, the continuous when passing wall on the floor, cable trunking Chevy accessible through its entire length. Cables are installed in the trunking channel, relying on the anti-release remove cover for the spoke, and also the NASA hydroscopic trunking Chevy used to the enclose the insulated and heated conductor. Light bars of the accessory must be mounted on the trunking Chevy array so that the base protection is provided. Enclosed wiring system means a mechanical protection achieved by the complete enclosure barrier between the wiring system and the possible source of the impact. If the cables are connected in conduit or the piping side enclosure Chevy test for the impact energy. So segregation method you have to utilize. So in this case, we have to utilize the Australian Communication Authority ACA standard AS and 3000 cross 3.9.63 or 3.9.8.4. They require the low voltage cable to be segregated from the cable of the other system, especially the technical communication cable. So that we have to follow the appropriate New Zealand Australian standard 2053 and also 71386 and also 4296 to select the type of the conduit. So those are today's lesson drawing and also the electrical terminations lesson. So this is for the trade 1. Now we're talking about the trade 2. Okay, electrical trade 2, we are talking about a GCC3 electrical protection. So in this case, the question asked, determine the current drawn by a 230 volt 6 watts 6 kilowatt electric top. So in this case, power wise 6,000, 6 kilowatts with a 6,000 watt divided by 230 and power factor 1. So that will be the current you can calculate it. Also the appendix C, cross 5.1. So problem 1 was a number of the circuit. So appendix C or the circuit that each item of the equipment has a current rating of the 20 ampere per phase should be connected to the spray distance of circuit. where the more than one item of equipment is to be connected to the circuit. So this is the number of points connected to the circuit is mentioned in the cross 5x1. Cross 5x2, so you have to read through the cross 5x1 or the AR3000. Also the paragraph C5x2 is we have to utilize the cables table C9, so it's provide the method that has been used to solve the addition of the standard. So this is for the cross 5x2, the final circuit. So the guidance to determine the number of socket outlets. So this is the table C9. Table C9 is how guidance on the loading of the point bar final circuit. How many sub-points can be utilized for the final circuit? So you have to refer the tables C9 of the AR3000. So they also for also the represented by the cross of C5x2. The domestic home is we utilize the TBS wire cable. In this case, domestic home of the 36 light 24 level 10 ampere socket outlet 1x2 125 ampere 1 about the 25 ampere single phase air conditioner and 1 about 3.6 kilowatts hot water system. So this way we have to follow the create this table here. So in this case the 36 light is a 10 ampere circuit breaker. So this is a 36 divided by 0.5 ampere per point. So that will be the 18 ampere. So in this case 18 light is the current 10 ampere protected by rating and number of point per circuit can be 18. Also the 24 doubles are 10 ampere socket outlet, so 20 ampere socket outlet, so 24 multiplied by 2, double means that in this case 48 point. So this is 2 ampere per point, so the 2 multiplied by 48, so this is 96 ampere. So find about double 10 ampere socket outlet. That will be find about that 10 ampere socket outlet is this is also 20 ampere. In this case, our number of point per circuit is 5. Find number 10 ampere socket outlet 20 ampere 5. And also the full number 10 ampere socket outlet 20 ampere, there's a number 4. And one about 25 ampere single phase air conditioner. This is for the 25 ampere circuit breaker. Means current is 25. And one about 3.6 kilowatt hot water system. The current is we already calculated the 16 ampere. So we add the all current. By this way, you can find out the to the current rating, protected by rating. So this is the kind of the protected by rating, and this is the number of point per circuit, and this is the kind of the equipment. So those are we have to refer the appropriate of this diagram, the loading of the point per final circuit. This one is utilized, and we will draw this load type, and also the protected by rating and number of point per circuit. So here is a diagram of the domestic home, diagram. The electrical installation diagram. Also, the commercial office wire using the TBS cable has the following load items. So this is 43 light, 23 number 10 and your socket outlet. So we have to follow this table. So in this case, we have to follow the cable schedule. So you have to follow those schedule appropriate AR3000 standard, and you have to do the day exercise. The next one is the circuit cable schedule. Circuit schedule are used to predict the protection divisor control, which a circuit domestic homes usually do not require the schedule due to the small number of circuit installed and assemblies are labeled the swivel or the distribution directly. Industrial commercial installation, the amount of circuit increase and the schedule are required. So this is for the cable schedule diagram, kind of the cable and the part number, and this is kind of the kind of the cables are the description. Those things have to be utilized. So they were scheduled are utilized for the industrial. Here is we also have to complete this diagram like this. Basic fault protection by use of the extra low voltage. In this case, a split extra low voltage SC level protected extra low voltage. In this case, fault protection extra low voltage. You have to refer to the cross 1/5/7 of the AR3000. So 5/7 is the basic and the fault protection by using the extra low voltage. So the expected extra low voltage SCLV or the protected extra low voltage PLV system may be used to provide the basis of fault protection subject to the following condition. The nominal voltage shall not be capable of the exceeding limits for the extra low voltage 50 volt AC or 120 volt free DC, and the source of the supply range so that it cannot exceed the value. Circuit shall be electrically separated from each other and from the circuit higher voltage. The light bus of the SCLV circuit shall not be connected to add or to protect the other connector. They are part of the other circuits or other light bus. Light bus of the PLV circuit shall be protected from the direct contact. and the barrier of the insulation unless the body does not AC the 25 volt AC or 50 volt reverb free DC in dry area where the large contact area with the human body is not expected to or the 6 volt AC or 50 volt reverb free DC in all area. So this is for the you have to read this clause 11557 based on the fault protection by use of the extra rule voltage. Also, you also have to read through this clause 5/7/5/3 solar supply of SELD or PELD system in the year 3000. So I write those things here. You have to read and arrangement of the SELD circuit. The clause 5/7/5/5 arrangement of the SELD circuit you have to read through. So then based on the clause 7/5/7 to 7/5/11, then you have to do the exercise 9. So this is for 7/5/7 circuit body draw, 7/5/9 is over body current protection, 7/5/10 is a connected devices, those things utilized to do the exercise. And also we have to clause 7/4/3 is utilized to do the arrangement of the circuit. So in this case, 7/4/5 is supplying to the single down electrical equipment, 7/4/6 for the supply to multiple items of electrical equipment. 7/4/3 so arrangement of circuit. Arrangement circuit are splitter circuit shall comply with the following requirement. Circuit voltage shall not exceed 500 volt. All light parts of the splitter circuit shall be reliably and effectively electrically separated from all other circuits. So this is a 7/4/3 definition. 7/4/5 the supply to single item of electrical equipment, where the splitter circuit supply the single item of electrical equipment and any exposed conductive parts of the equipment shall not be connected to the exposed conductive part of any other circuit, including the others splitter circuit or R. So you have to read this 7/5/4/5 supply to single item of electrical equipment. Also 7/4/6 also have to read supply to multiple items of electrical equipment. So in this case the supply to multiple items of electrical equipment where the splitter circuit supply the more than one item of electrical equipment. The following requirement applies. Is any exposed conductive part of the splitter circuit shall be connected together by an insulated equal potential bonding conductor that is not connected to the earth or the any protected agent conductor or the any external conductive part. So the exposed conductor the meaning the silent agent conductor of the socket outlet installed on the splitter circuit shall be connected to equal potential bonding conductor. Exposed conductive part of the source of the supply, there are other shall not be simultaneously accessible with any exposed conductive part of the splitter circuit. A protected device shall be separated operated to disconnect the splitter circuit automatically in the event of the two faults resulting in the exposed conductive parts being connected to the live bars of the different polarity if the protected device is a circuit breaker. So and also we have to read through the 2/3/1 of the year 3000. Electrical installation shall be provided with the devices to prevent all the remote hazards associated with the electrical installation for the maintenance of electrically activated equipment. So those things you have to read the 2/3/1 of the year 3000. This is that you have to read the 2/3/1 of the year 3000. And also the which section of year 3000 set out requirement for the general arrangement. This is the 2/1. So and selected by the control the electrical installation circuit, consideration need to be given for the suitability of the device including the IB rating. So in this case the selection of installation you have to refer the clause 2/1/2 and selection of installation. It mentioned about the switch gear and the control gear shall be selected installed to perform the following function. So this is the function of the switch gear and control gears function. Those things are mentioned in the clause 2/1/2 of the year 3000. Similarly, clause 1/4/64 are mentioned about the isolation function. So in this case, you have to refer the clause 1/4/75. So this is the isolation function. So isolation function is reason for the safety. Function or the identity to cut off the supply from the full installation or the discrete section of it, separating it from the source of the electrical energy. So then in this case, across our 1 by 5 by 2, this is mentioned about the control isolation. So this is the clause 1 by 5 by 2a mentioned about the control isolation. Electrical installation shall be provided with the control isolation devices to prevent or to remove the hazard associated with the electrical installation and to allow the maintenance of the electrical equipment. So this is the control clause 1 by 5 by 2 mentioned about the control isolation. In this case, our control safety devices need to be arranged. In this case, they are separated from the control other equipment are not the intentionally interrupted by the operation of the other equipment. So the isolation devices are need to interrupt all the isolation devices, all active conductor required to be interrupt and also to operate in a neutral conductor. Isolation devices shall not interrupt. So and it shall not interrupt other conductor. And also that you have to refer the clause 2 by 1 by 2 and selection and installation, and then you have to answer the both answer. And also the refer the clause 2 by 3, to control electrical installation, you have to refer the clause 2 by 3 and do the date exercise. So this is for this clause 2 by 3 and do the exercise. Also the clause 2 by 3 and also this clause 2 by 3 by 2 to refer and then this do the date exercise. Clause 2 by 3 by 2 is a common control requirement. So the 2 by 3 by 2 by 1 by 1 is an all system. 2 by 3 by 2 by 1 by 1 alternating current system. 2 by 3 by 2 by 1 by 2 is an alternating current system. 2 by 3 by 2 by 1 by 2 alternating current system. Also, are there any exceptions that will allow the neutral consumer made neutral or PM conductor to be strict or isolated? So answer is no. So this is the answer for the PM. Maybe the isolation device placed in the circuit other than consumer neutral or main neutral PM conductor. Answer is yes, because we will follow the 2 by 3 by 2 by 1 by 2 or the current system. This means the provision of the isolation conductor in AC system are as follows. Every conductor or every conductor of the AC circuit shall be capable of being isolated by the device of the isolation. And this connection earlier permitted straight adding conductor PM. So answer is no, because of the you will follow the clause 2 by 3 by 2 by 1 by 2 direct current system. Common DC system include the output of the photos PV system, extra low voltage system, battery backup system, some machine control circuit, and the light. So read the requirement in this clause and answer the following. So this is for the read the clause 2 by 3 by 2 by 1 by 2 and direct current system. All conductor DC circuit shall be capable of the being isolated by the devices for isolation. So this is the device for isolation. You can do the exercise. Should the isolated device rarely available accessible? Answer is yes, because the shall be rarely available. According to the clause 2 by 3 by 2 by 1 by 1 and or the what current should isolation device be able to safely interrupt. So in this case, we refer the 2 by 3 by 4 by 1 electrical installation and outbreeding. So they mentioned about outbreeding, how much the maximum demand current. Also the general measure, we have to refer the clause 2 by 3 by 3 by 1 general measure function. So this is they mentioned that the supply to every electrical installation shall be controlled on the main switch board by a main switch or the switch that control the whole of the electrical installation. Where the multiple supplies are provided, each supply shall be controlled by a main switch or switch on the main switch board for each supply. How should main switch board be identified? So the main switch board shall be located, arranged, and legibly and permanently by the identified. Crossing with the clause 2 by 3 by 3 by 3 or to the 2 by 3 by 3 by 5 to allow for their effective operation in the emergency. So the 2 by 3 by 3 by 5 is the identification. Main switch shall be identified as follows. Main switch must be the marked with the main switch or the where the modern main switch in this case shall be marked to indicate and opening of main switch bring to the operation of isolated alternate supply. In this case, you have to write this as notice. Also, main switch shall be a supplementary or the alternate supply shall be labeled indicate the energy source. So those are definition of the main switch. How to install the main switch, you have to follow those in standard. It's also the required by the clause 7 by 2 by 3 mentioned about the main switch board or the switch gear It's 2.3.1 is the general information. Those things are how the main switch box need to be controlled, and what the requirement is important. And also the part 2, there's a clause 2.3.3.2 number of main switch. So the maximum number of main switch commented in the domestic installation. So in this case, we have to apply the 2.3.3 number of main switch. The number of main switch shall be kept to the minimum practical to the provide the effective operation in the emergency. Domestic electrical installation, including each separate the domestic electrical installation, forming part of the multiple electrical installation, shall be provided with the not more than about one main switch for the each separately meter supply, or where there is more than one separately control supply from a meter, a main switch or the each separately control supplies. How many main switch should be required to domestic installation at the office? This answer is 1. So this is the things answer. In this case, I block the 2 units at the 3 meter, 1 per unit, 4 meter for common lighting. How many main switch shall be on the main switch board? In this case, answer is 4. Where there is a more than one separately control and supply for a meter and main switch or each separately control, the main switch will have to verify the clause 2.3.3.3. This is location. In multiple installation, living unit flat, in this case, they must have the basic main switch or the general main or the isolated switch shall be installed on the main switch board in the outbuilding to control the electrical installation in the building. So main switch identification, you have to refer the clause 2.3.3.4. 2.3.3.5 is an identification of the main switch. So they mentioned about the main switch should be identified. So this is the 2.3.3.5. So the main switch identifications procedure. Also the requirement to identify ensure the electrical supply is not inadvertently disconnected from the electrical supply. They require to operate during the emergency situation. So this is also important and this important. Clause 2.7.2.1.1 mentioned about the scope. The particular requirement for the clause 7.2 apply to the electrical installation of building service. They are essential for the safe operation or the safety services. Consistent of the fire detection, warning, and the execution system and smoke control system, evacuation. So this is 7.2.1.1 and mentioned about the scope. 7.2.2.3 is an alternate supply system. So this is the thing. So that based on the door thing, you have to do the door exercise. So these are escalator, moving way, traveler, traversicator. So this is the mentioned about, and you also do the door exercise. So the type of the injury occur, in this case, there's a kind of the injury. There can be the electric burn on the unexpected mechanical movement. Example, electrical installation means the shutting down of mechanical maintenance. So in this case, electrical installation that requires shutting down the door of the equipment to be shut down. The device for the shutting down, in this case, the device for shutting down, this is for the manual operation. Also, they indicate the off position designed for install so that they prevent the eye attention and closure. So this is the 2.3.6.2. This is the mention about the devices for the shutting down. 2.3.6.3 is a mention about the installation. So how the installation method. So 2.3.6.4, they mentioned about the identification of the electrical installation, how the shutting, if you want to shut down the mechanical shut down for the mechanical maintenance. In this case, all equipment need to be identified. Switching devices are also, the switching devices are the starting and stopping motor, emergency stopping, isolating motor. Those are the clause 4.13.1.1 mentioned about the switching devices. 4.13.1.2, this is the rating of the switch. Rating of the switch that must be the full load current rating and the control circuit current. So that the isolation circuit shall have the rating of the not less than the full load current of the motor when installed directly in motor supply, or that the controls of the circuit current when installed in the motor starter circuit. So this is the mention about the clause 4.13.1.2. So each of the default value used to determine the load motor current. So in this case, 8 times the full load current of the AC motor, or the 4 times the full load current of the DC motor. And also that we are talking about the functional control switch. The functional switch are required. Functional control switch are the may be utilized for the switching of the electrical equipment. The part of the electrical installation required for operational control only. And switching devices, cooking appliances, in this case, we refer the circuit for the fixed or the stationary cooking appliances, having a open cooking surface, incorporating electric heating, cooktop, deep fat fryer, barbecue grill, or similar, shall be provided with the switch operating in all active conductor are the mounted near the appliance in a visible and rarely accessible position. So function as switch the cooktop is a how much switch shall not be mounted on cooktop appliance. The switch shall be mounted within 2 meters of the cooking appliance. And does a built-in wall oven require functional switch? Answer is a no. Because of the clause of 4x7x1 is a mention about the switching device. They mention about the circuit for a fixed or stationary cooking appliance, having an open cooking surface, incorporating the electric heating, cooktop, deep fat fryer, barbecue grill, similar, shall be provided with the switch operating in all active conductor mounted near the appliance in a visible and rarely accessible position. Also, we are talking about the page 67. So, in this case, selecting the circuit breaker for water heater final circuit, current rating should be equal to less than demand of the final circuit, equal to the greater than demand of the final circuit, equal to less than given rating. So, this is the we have to refer the clause of B3/2, the coordination between conductor and the overload protected device. Also, this is for the quiz 441, 442, you have to read through. This is a rating of the circuit breaker. So in this case, selecting the circuit breaker for water heater final circuit, its current rating should be equal to or greater than the amount of final circuit, equal to or less than the given rating. So this is a appropriate theory, AS3000 rule, coordination between the conductor and the overload protected devices. So this is the mentioned about the clause of B3/2, as well as the page 442 that they mentioned about. A straight final circuit recommended for any single point of exceeding 20 ampere. Because of they mentioned about the number of points connected to the circuit. This answer is each item of equipment that has a current rating of the 20 ampere per phase should be connected to straight distinct circuit. This means that straight final circuit recommended for any point or load exceeding 20 ampere. If the current is more than 20 ampere, you have to do the straight final circuit important. Recommended number of lighting pipe that can be connected to circuit wire in 1 millimeter square TPS cable produced by 6 ampere type. So in this case, the number 12. So this is it. 12 is it. Because of the 6 ampere divided by the 0.5 ampere per point, so this is the 12 point. And also read through the calculation. This one, this is the appropriate table. Guide all the loading of the point by finance circuit. How many points can be connected? You have to refer the table C9. By referring the table C9, we calculate the lighting point to be connected to the 1 millimeter square TPS cable. This is what we have to refer the table C9 of the AS3000 to determine the number of points that can be installed in the finance circuit. And also that the switch used to isolate the 12.5 kilowatt range cooktop oven that is connected to the two-phase and the neutral will have a minimum of 3 volts. For the single domestic installation, maximum demand less than 100 ampere, the maximum number of main switch per turret is 1. In this case, also you guys will refer the AS3000 2.3/4 additional isolation switch, 2.3/4/1 the electrical installation in outbuilding. And electrical installation in the outbuilding shall comply with the following. General electrical installation outbuilding shall be treated as a straight electrical installation. It has a maximum demand of 100 ampere mobile field and is provided with a switchboard. The main switchboard should be located as close as possible to load. It isolates the main switchboard. And also the clause 2.3/3/2 the general. In this case, where the multiple supplier provides each supply shall be controlled by the main switch or main switchboard for each supply. The maximum permissible height for the main switch for switch above the ground is at 2 meters. Because of the we refer the clause 2.3/3/4 location and operation. Main switch shall be accessible at following. The general main switch shall be readily accessible and the mains of the operating switch shall be more than the 2 meters. Also, then it is not permitted to install the isolation switch in the nuclear conductor or protected earthen conductor. Also, then we also read through the 2.3.2.1.2 or ordinary current. No switch or circuit breaker shall be inserted in nuclear conductor. Switching at the earthen conductor is prohibited the earthen conductor because of the we refer the 2.3.2.1.2. In this case, conductor shall be used as a combiner protected earthen and nuclear. Then conductor shall not be isolated or switched. So this is the cross 2.3.2.1.2 of the AS3000. So this is appropriate door exercise you have to do. This is the exercise. This is the answer for the door exercise. So this is all the cross are 2.1.4.105 extra low voltage. You have to read through. Cross 1.4.96 protected extra low voltage. And you have to read the cross 1.4.128 the voltage, and also the 3.9.8.2.2 is segregation. So in this case, the circuit or the low voltage circuit and cable extra low voltage circuit shall only be enclosed in same wiring system where the one or following arrangements is employed. The low voltage cables are type of providing the equivalent of double insulation. All cables or the e-conductor or multiple cables are insulated for the higher voltage present. So this one also the cross 7.5.5 is mentioned about the arrangement of the SCFE circuit. So other circuit are condition, earthen condition. Similarly, base 71 is a auto transformer. You have to read the 4x40x4 auto transformer. And 7x5x7 is voltage drawing conductor. Let's also read the voltage drawing conductor. 7x5x5 is the arrangement of the SCFE circuit. 7x5x4 is a separation arrangement for SCF or BAppEngLesson circuit. Those are the AS3000. How the separation requirement for the SCFE BAppEngLesson circuit. You have to read the thing. 7x5x5 arrangement of SCFE circuit and split the circuit or the required for the circuit voltage not exceed the 500 volt. So you have to read the whole thing. Can the equal potential bonding conductor connected between socket outlet or isolated circuit connected to the equal potential bond ambient system? Answer is no, because of the we refer the cross 7x4x6 supply to the multiple item electrical installation. Any exposed conductor pass on the splitter circuit shall be connected together by insulated equal potential bonding conductor that is not connected to earth. So today's circuit, we provide the answer for the G063, page 31 to 64. So this is for the trade 2. So now we are talking about the applied electricity DC circuit. This is for the Bachelor Applied Engineering. We're talking about the lesson 3 and 4. Applied electricity DC circuit, we're talking about the electron theory. So in this case, our basic electrical circuit, this is open switch, closed switch, the battery, this is borosole, this is lamp, this is the voltmeter connection, the ammeter connection, and this is fuse. So those are the diagram symbol of the open switch, closed switch, battery, borosole, lamp, fuse, voltmeter, and ammeter. So this is connection of the voltmeter, fuse, switch, ammeter, and lamp. So this is measurement of voltage. This is a DC meter. This is reading 32 ampere. This is 11 volt. The DC meter 15 ampere. This is 17.5 volt. So at the end of this session, students should be able to list the 3-stage method and the final associated term, draw the Bohr model or atom and the name, the path, define the calculate the electrical charge, and describe the electrical properties of material. Define the starting time associated with the electrical material. Describe the mechanism of electrical current flow in solid, liquid, and gas. So this is for the atom. So this is nuclear. Nuclear, this is electron moving around. This is the proton, and the neutrons are at the nucleus. Atoms are made of the 3 basic particles. Proton carry the basic positive charge. Neutron carry no charge. The proton and neutron join together form the nucleus, the central part of the atom. Electron carry the negatively charge and the circle the nucleus. So in this case, the middle part is the nucleus. Nucleus includes the proton and the neutron and the electron moving around. So here is the orbit. This is a neutron, electron, those are the orbit. So this is the inside the atom. So in this case, the atom always has the electron, proton. Atoms are usually about as many a neutron as a proton. So this is hydrogen, is a 1 proton and 1 electron. There is a 0 neutron. Helium got the 2 proton, 2 electron, and the 2 neutron. Carbon, 6 proton and 6 electron, and a 6 neutron. Adding the proton make the few kind of the atom. Adding the neutron make the isotope of the dead atom and the heavier version of the dead atom. So this is the atom has as many electrons as a proton. Atom usually have about as many neutrons as a proton. Matter can be classified as a substance. There are hundreds of substances which are called the elements. So they are the kind of the this is the periodic table element. So this is the hydrogen. Hydrogen are mercury, Ag. This is boron. So this is the atomic weight. Substances are made of the 2 or more elements are called the compounds. Some of the compound, there will be the compound with the nitrogen and chlorine compound. This is nitrogen chloride. So this is nitrogen chloride diagram. Hydrogen and oxygen compound, we call it the water. So this is called the 2H2O. 2H2 plus O2, then there will be 2H2O. So 2H2 is a gas, O2 is a gas, but the H2O is a liquid become. Liquid has a very different properties than the gas. So there are the diagram: oxygen, hydrogen, carbon, nitrogen, chlorine, fluoride. So this is carbon dioxide. Then this is the ozone. This is H2O. This is nitrous oxide. This is CFO, carbon fluoride. CH4 is the methane. Those are combination of the carbon, hydrogen, oxygen, and then we can call the substance compound. Substance which do not have the combined chemically are called a mixture. Why and water they not mix together? I am filling the Y. So this is the isotope hydrogen. So the hydrogen 1, helium is a 4, lithium is 6, sodium is a 22. In this case, the number of the electron here is a red is a number of the proton, blue is a number of neutron. So isotope of hydrogen, helium, lithium, and sodium. Electron inside the outer orbits are called the free or the valence electron. Electron as the outer orbits, they are running. So this is the outer. The electron is outer. This is electron is outer. This is the free electron. They can move from the one atom to another atom. Material that have the loss of the free electron, they are called the good conductor. There are many free electron. They are good conductor. Very few are free electrons. This is a pure conductor. Steel, copper, aluminum, silver. They are the good conductor or poor insulator. They got the a lot of free electrons at the outer orbit. They are metal, steel, copper, aluminum, silver, gold. They are the poor conductor or poor insulator. Few free electrons are the good insulator or poor conductor. For example, rubber, plastic, mica, wood. They are the non-metal. Non-metals are the good insulator or poor conductors. So this is the atom, the neutral atom. Neutral ion, they got a 4 proton and a 6 electron. There's no charge. But the positive ion, in this case, are 4 proton and a 3 electron. So that will be positive charge. Here is a 4 electron, 4 proton. Red are 4 proton. The outer orbits are the 4 electrons. So they are neutral. But here you see the 4 are red, 4 red color, but the 3 outer electrons. Therefore, the 4 electrons is positive, 3 electrons is negative. But the positive are more. This is when this ion called the positively charged. Negative ion means that this is the number of the electron. This is you can see the 5 electron, but the only 4 proton. So there will be negative charge. Charge react with each other. Unlike charge, they are attract. Like charge, they repel. So conduction in a gas by the movement of the ion. So the ion coming from the positive of the DC source, the movement to the positive ions are moving through now, and also they go to here to the other opposite terminal. So here in that gas. So they are movement, conduction gas movement by the movement of the ion. So the conduction in liquid is also the movement of the ion. So you see that this is the supply electrode connected, the current flow, the red color, current flow, this is become the anode, and this is the become the positive charge, positive passing through to cathode. So conduction is solved by the movement of electron. So this is the movement of electron. When the electrons are the moving around, so electron flow is this diagram. The electrons are flowing. Electron flowing like this. And this is conventional current flow is positive and negative. So we connect the DC power supply to the light. So this is switch. So we make the MBR. So in this way we join the circuit together. So this is all the lesson 1. And we're talking about the lesson 3 and lesson 4. Nói này lâu lâu mà on lên này. Đây này lâu lâu này.
Lại kìa.
Xếp bằng cái pha.
Mà chào chào kìa con mày. Thì yêu quý rồi đẹp bộ. Thì không phải. Mau chết đẹp bộ.
Okay, we're talking about this DC circuits own law. In this case, electronic theory. So this is connection of the switch circuit diagram. Also that the voltage, when the voltage increase, current will be increased. And this is the median of the ammeter, voltmeter. So at the end of this session, students should be able to state their own laws, use their own law to calculate the voltage, current, and resistance in simple resistive current circuit, define the starting time associated with the electrical circuit. So in this case, the own law state that provided the temperature of the given conductor remain unchanged, the ratio of the potential difference between its and the steady current is a constant quantity. So V by I ever constant. We got this content. This is where resistance. Resistance is a measure of the conductor opposition to electric current. The formula transportation, this is RVI. Resistor, I equal to V by I. Voltage is I multiplied by I. Current equal to V by R. So this is our 12 ampere. Sometimes we 12 ampere current resistance 10 ohm. So the current we 120 divided by 10. So we have 12 ampere. And this is sometimes we 240 volt. Resistance 10 ampere. So this is a 24 ampere. The increase in applied voltage gives the proportional increase in current. The current is a direct proportional to applied voltage. I direct proportional to V, or the I equal to V by R. So in this case, this is the exercise for the increase in resistance gives the proportional decrease in current. Because the supply 120 volt, resistance 10 ohm, so current flow is 12 ampere. Supply 120 volt, resistance 20 ohm, current 6 ampere. This means the increase in resistance gives the proportional decrease in current. So the current inversely proportional to resistance. I equal to inversely proportional to resistor. Resistance is a conductor. The electrical conductor is a measurement of the conductor is capability to conduct the electric current G equal to 1 by R, or the G equal to I by V. So this is the DC power supply, V connection, and this is a connection diagram. So the lesson 4 that on this session, students should be able to analog the digital meter to measure the resistance, use the analog voltage and current meter to determine the current resistance, describe the two methods of connection of voltage and current meters to determine the circuit resistance, compare these two methods of connection. So resistance measurement, so this is for the digital meter, this is analog meter. Isolation resistance measurement, we use the mega. Which normally is we use the measurement of resistance. where R1, R2, R3, R4, and VB and VD are equal, that way 0 volt. And gamma number G indicates a 0. So the gamma number G, R2 by R1 equal to R4 by R3. If R2 is only unknown, then R2 equal to R1 multiplied R4 divided by R3. Sham method is a sham method, also use R equal to V by I. This is long sham method. And this is a short sham method. So long sham method and a short sham method. Supply voltage 99 volt, current 500 millimeter, I equal to V by I, so 99.5, you got the 198 volt. Long sham method, voltage 100 volt, I is a 300 milliampere, so the I equal to V by I, so 100.3, so 333 ohm. So this is long sham method and short sham method diagram. Now we're talking about the lesson 5. So we're talking about the effect of electrical current. Revision, we revise the Ohm's law. So when the voltage increase, current increase, voltage increase, current increasement. So this is a connection of the electrical circuit diagram. The reading of the voltmeter, ammeter. And this is resistance measurement, reading of the meter. Okay, at the end of this session, students should be able to list the effect of electric current, describe the effect of electric current is some example of the practical application, connect the electrical circuit to demonstrate the effect of electric current. The effect of electric current means that as a current flows through the conductor, friction causes heat. The current flow through the conductor, it causes electron always to align and producing in the magnetic field. If the current flow in the electrolyte, it causes a chemical reaction. Also, it can happen as psychological impact. It is always present when the electrical current flow. Harmful effects, they can be the unwanted heat, damage to conductor, and cause of fire. Useful effects is that we use for the cooking range, heater, frying pan, and refrigerator. Also toaster, incandescent lamp. Magnetism, when the electrical current flow, it can create the magnetic field around it. So this is the current diagram, which the current coming, the electric magnetic field is around like this. So the magnetic field will be this direction. So this is the currents are this way. This is the flowing to what? This is flowing away. Flowing to what? This is a magnetic field direction. Flowing away, this magnetic field direction. The current opposite, that will be the magnetic field will operate. So that will be the flowing away. This diagram, the flowing through. You can see this way. So magnetism is present when the current flow. The harmful effects are the attracted matter, distortion of radio wave. Useful effects are electromagnets and the motor. We can also use the generator, relay, and conductor. Audio recording and microphone. Chemical effect. When the electrical current flow, this is a chemical, so this is the electrode. This is the electrolyte. So the current flow like this, they become the anode. The current, this is the positive proton, positive charges, they flow to the negative charges passing through electrolyte to the cathode. So chemical effect. Harmful effects are the corrosion. Useful effects are corrosion, rust. Useful effects are electrobreaking, electrolysis, battery charging. Psychological effect. Harmful effects are the muscle spasm, pain, pain, stop breathing, death. Useful effect is defibrillator, stun gun, electrocardio, and electrofans, cardiac production, press. So those are psychological effects. The body system operates in response to the electrical impulse from the brain. The two most important muscles for survival are the heart and the diaphragm, both located in the chest. The power of the electrical current through the body is important. How much current can the body handle? current and effect. Up to 2 milliampere, barely noticeable. 2 to 8 milliampere, sensations are noticeable and more painful. 8 to 12 milliampere, muscle spasm and more pain. 12 to 20 milliampere begin to lose muscle control. 20 to 50 ampere could stop the breathing. 50 to 100 milliampere could stop the heart. 100 to 200 milliampere will stop the heart. About 200 milliampere, all the above and the severe vermin. So what affect the amount of the current in body so that I go to V by R, the current part, the longer the part, the higher the resistance, the condition of the part. Where all the damaged skin has a lower resistance than the into the dry skin. Then we are talking about the electromotive for EMS so that. So that the objectives are these are three main methods of the converting energy to electrical energy. These are two examples of electromotive source for the e-conversion method. Describe the principle of operation of common energy converter. Describe the difference between the primary and secondary cell and draw the equivalent circuit of the EMS source. Mechanical energy conversion, then can convert with electrical energy. So this is the energy conversion, the friction between two bodies based on the static charge. Mechanically driving generator use magnetic properties to create the differential potential difference. So this is the kind of the piezoelectric crystal. Piezoelectric crystal mechanically energy convert to electrical energy. Friction between two bodies based on the static charge. Mechanically driven generator use magnetic properties to create the potential difference, and this is the function of the piezoelectric conversion, energy conversion, mechanical energy to electrical energy. Now so we're talking about the chemical energy conversion process. So here chemical energy conversion, electrical energy. We use the electrode in the electrolyte to produce the potential difference between the electrode that they can be used as the primary cell or secondary cell. And radiant energy. Never radiant energy. So this is the energy conversion process. Now and the radiant energy. So this is energy converted by electrical energy. He can produce the potential difference between dissimilar methods. He can produce a potential difference between dissimilar methods. So they are thermocouple. And in this case, we use the photovoltaic cell. Photovoltaic cell convert the sun energy to electricity. So this is the thing. So now we're talking about the voltage equivalent source. Ideal voltage source and zero internal resistance diagram. And internal resistance diagram is this one. So that we had to talk about the effect of the basic current. So this is for the applied electricity, bachelor of applied engineering degree aspect. Now we are talking about the diploma. Diploma, we read about the E082's engineering physics. So we go to the source, and it's both sides. Okay, we're talking about the electrical diploma. So the website is www.iuengineercollege.com/electrical diploma 2022.htm. So this is the website www.iuengineercollege.com/electrical diploma 2022.htm. So go down here, we can see the video lesson. Go down to YouTube video lesson for electrical engineering lesson. You click the this side, then you click the lesson. We have all these I ask you to view the video of the E082 engineering physics. So engineering physics are the lesson for the written notes for the those lessons you can read from the page 58 to 86 highlightcomputer.com/video lesson. So you click this side. So then there you can see this is the written notes. Written notes for the video. So those video lessons are the written notes. So you have to read the page 58 to the 86. Then you can get the written notes for the video. So those video lesson written notes is this one. You have to read the page 58 to 86. So 58 to 86. So this was we are talking about a linear motion, circular motion, and go to the 86. 58 to 86. So this is a written note. Written notes for the video lesson. All the video lesson written notes are you can see from the page of 58 to 86. So you have to view the video and written notes and read those written notes. Page 58 to 86. So those 86 are then you can see all the last week we talking about the lesson 13. Now you have to read the lesson 14, lesson 15, lesson 16, lesson 17, lesson 18, 19, 20, 21, 22. So you have to read through the lessons up to lesson 22. Lesson 13 to lesson 22 you have to read. You view the video.
View the video.